All right, a 20-kilogram crate hangs at the end of a long rope. So we got a rope. 20-kilogram crate. What is the tension in the rope? What is the acceleration of the crate, magnitude and direction, when the tension is 50 newtons? So what is acceleration? So 50 Newton tension gives us an acceleration of what? All right, so let's consider the first part where the crate is not moving. So it's just hanging there, and they say, what's the tension in the rope? So the forces that are acting on this thing are what?
Gravity.
You have gravity pulling this thing down, and tension in the rope pulling this thing up. And I don't believe there's any horizontal forces acting on it.
No. So we have F of, is that the natural force or the just gravitational force?
Just, yeah, just the
so then
gravity.
That's 9.8 times 20.
There you go. So this force is mass times gravity.
9.8 times 196.
196 newtons pulling downward.
Mm-hmm.
So the tension in the rope should be what?
196.
Can I use a piece of paper?
Wait. If the tension is 50 newtons in the rope, how much is it accelerating?
Yeah, so hang on, let's make sure we're clear on the first part. So if this crate is just hanging and it's not moving, it's not accelerating in any direction, if there's no acceleration, if acceleration is 0, that means there's no net force.
What do you mean there's no net force?
What is the net force?
So net force means the sum of all the forces
Look,
combined.
there is a net force. If it's gravity and then tension, those combined would be the net.
And they cancel each other out. So the net force is equal to 0.
Never mind.
Yeah? Do you see what I mean?
Yeah.
So there's a force pulling downward on this thing, and then the tension is pulling upward, and they cancel each other out, and then you just have this crate just hanging still, not moving. Yeah, so if there's no motion, there's no acceleration, that means there's no force. So if we know the force of gravity is mass times this 9.81 meters per second squared deal, then we know that the force, gravity wants this thing 196 newtons worth of force. Yeah?
Mm-hmm.
And if it's not moving, it's not accelerating, then there has to be an equal and opposite force. Yeah?
Yeah.
So therefore, we could call this 196 newtons and we could call this negative 196 newtons.
Or flip the signs around.
Yeah, either which way. Whatever you want to, if you want down to be minus and up to be positive, whatever blows your hair back. Yeah? Okay, so that's the tension in the rope if the crate is not moving. Now it says, if there's only 50 newtons of tension in the rope, then how fast will this thing be accelerating? Because we need 196 newtons to keep that thing from going anywhere. But if there's only 50 newtons, it's going to start accelerating downward. Ella?
Then can we subtract or like take 50 away from 196 and then add it to the 196 on the bottom to get the total force?
Here's what I want to do since motion is going to start going this way, right? Let's make the direction of motion be positive. I like making my direction go in a positive way. So, so yes, in part B, if this is negative 50 newtons, force equals mass times acceleration, then this force becomes the sum of forces.
Is that what that ZMW thing means?
Sigma?
Yeah, that.
Yeah, the sum of forces. Guess we didn't do any of that in algebra 2, did we?
No.
No, so pre-calc you'll see this sigma just means add stuff together. So if you saw the sum of, oh damn, I don't know if I want to give you a whole lesson in this right now. Yeah, maybe not. It just means add stuff.
Okay.
Yeah. So the sum of forces, and these are vertical forces, so we can say F sub y is going to equal the mass times acceleration. So what's the sum of forces? 196
146
and minus 50
is 146.
is mass times acceleration. So 146 newtons equals our mass
20.
times our acceleration. So to solve for acceleration,
Yeah,
7.3
meters per second.
squared. So that'll be the acceleration downward. Cool?
Yeah.
Kai?
Yeah.
Is that alright?
Yeah.
So yeah, this idea of net force is key. Right, so let's take a look at number 2.
What are we doing?
The quiz review.
Wow, it is.
Yeah, do you have one of these?
I left all of my stuff at home. So I.
Because you thought it was the college thing today.
Yeah. I
All right,
can look up what we're doing on the board.
I thought it was crazy, but apparently everyone thought it was today. Alright,
Wait, you have one?
This is the one we got. Yeah.
I just handed them all out.
You can use mine. I'm probably.
Thank you. No, wait. Here's another one with answers on it.
Okay.
Ah.
So there's that one.
A 75 kilogram box is slid along the floor. Slid along the floor by a 600 Newton force. So this force is 600 newtons. The coefficient of friction between the box and the floor.
What's the coefficient?
It's mu, right?
Yes, and it's kinetic friction because that thing is sliding. So mu sub k is equal to 0.5.
What's the difference between saying coefficient of friction or force of friction?
Coefficient has no units. Force is of force. It has units of newtons.
So like if they gave us the force of friction, we wouldn't need to know the coefficient because we have the coefficient to find the force of friction, right?
So how does it help us if we have a coefficient?
The coefficient
Forces.
is the force of friction divided by the normal force. Isn't that right?
I don't know.
Yeah, that's right.
No, but the force of friction is going to be less than the normal force, and this coefficient is going to be less than 1. And newtons divided by newtons cancels. Yeah.
Yeah.
Right, so the force of friction is a force that's acting on a thing. This coefficient is just a property of the two surfaces.
Oh, so it doesn't have, so if you say it's a coefficient, like the surface has a coefficient of this friction?
Yeah.
Rather than it is, like that is part of the force.
Yeah, force is like an action,
So if
and
you
this is
said
like an adjective.
So if you say this box is sliding like that, and the coefficient is that, it doesn't necessarily mean that that box has a friction force. It just means that
Correct.
the surface has that.
I mean, if it's moving, then yes, there's a friction force. But I see what you're saying. Hang in there. You'll live. Find the acceleration of the box. Alright, so we have a force of motion this way. Where do you think we should draw the friction force?
That way.
Yeah, it will oppose the motion.
Wait, is the friction force 0.5, or do we have to find the friction force using that 0.5?
We have to find the friction
So
force.
what's the equation for friction force? It's like F of F equals mu times the force of gravity times the mass or something.
So, well, we'll use this.
Oh.
So, the force of friction is some fraction of the normal force. Right, so you just take the normal force and multiply it by our coefficient.
The normal force is 600 newtons.
I think it's
Well, we're going to have gravity here and normal force here, equal opposite.
Okay.
So let's figure these out. What is the weight of that?
75.
Times 9.8.
That's the mass of it.
Oh, 735.75.
I got just 735.
Okay. Well, we can. It doesn't really.
Use 9.81.
Yeah.
Use
Oh,
9.8.
okay.
Yeah, I think the book likes 9.81.
Okay.
So if you use 9.81, what did you get?
375.75. 35. No, a 5
Seven?
after that, and then a 75.75.
So that's 736 newtons.
My noggin is cooked.
Can we do that?
Yeah.
And so what's the normal force?
Oh, 736 newtons.
Yeah. Because this thing is not accelerating vertically. It's not moving up or down. So it has to have equal and opposite forces that cancel out here. Okay? And again, we can make this positive and this negative. But I think you get the picture.
So then we have the normal force.
Yes!
So now we go F of F, or the force of friction equals 0.5 times 736.
Exactly. It's going to be half of this. So 368?
68, yeah.
Yeah? So this
Wait,
is...
So
Right, so our coefficient of kinetic friction is 0.5 times our normal force is 736.
Yeah.
And that's our friction force, 368. Now again, we want to find the acceleration. So, anyone know any equations?
Wait, well,
Math.
no, but now we have to take that away from the 600 newtons, right? It's like the
Right.
force is 600 minus 368.
That's the net force.
Exactly, the net force. Now you guys are getting the net
Wait,
force.
what's the net force?
It's the sum of all
Oh.
forces.
Okay.
It's the one that does the movie thing.
wait,
It's the one
No.
that moves stuff.
Spider-Man's movie.
So, if we add up all of our forces, let's call this motion is positive,
how
and
does that help us in any way to add up all the forces?
because the net force tells you what the motion is. So, if we have a 600 newtons this way and 1,000 newtons this way,
It's going to be moving.
the net, yeah, it's going to be going this way because the net force is going to be 400 in this direction. We need to add them all together.
Well, we know it's going to be going that
Or
way.
I used to.
Yeah, but it's not going to be 600 is not going to tell us how fast it's moving.
You have to subtract the
Exactly. All the forces matter. Yeah? Okay. So, what is the net force?
233-ish.
Let's say 232, bruh. Is that okay?
Yeah.
So 600 minus 368 is 232. That is the net force in the x direction equals mass times acceleration. Let's divide that by 75. Solve for the acceleration.
3-ish.
Yeah. Very true. Does it round?
3.1. It's 3.1.
3.1 meters per second squared. Can you close that door, please?
Okay.
Wait, so the thing, that's the net force, not the normal force?
So this applies in any direction. So you can say that the sum of x forces equals mass times acceleration in the x direction. Or you could say that the sum of y forces equals the mass times acceleration in the y direction. But the sum of y forces is 0 right now, which is why the acceleration is also 0. But so this FMA works either in x or in y.
But net thing isn't an x or an y. A net force isn't an x or an y.
Yes, we're gonna break it down into x or y.
No, so the equation or the formula works for net force, normal force, and the x and y force.
Force, any force.
Any force.
Any force. This is true for any force. But it's useful for us if we can decompose this thing down into x and y, because we can look at it and say it's not moving in the y direction. So we don't care about the y FMA. We're going to only focus on this x FMA. Yeah? Kai?
Yeah.
As x.
We have to worry about the y stuff in the next problem.
Yeah, okay. Are we ready for the next one?
Yeah.
So I think it's important to draw a picture and then draw all of your forces. Right? Like there's motion, there's friction, there's gravity, there's normal forces. Just draw all of your forces with arrows, and then you can start FMA-ing and finding net forces all over the place. So we have a 35 kilogram wagon that's pulled along level ground by a rope. So we have a wagon, and it's being pulled level ground, and there's a 20-degree angle above the horizontal. A friction force of 12 newtons opposes the motion. So I'm going to say we're pulling it this way, opposing the motion this way, 12 newtons. How large is the pulling force if the wagon is moving with an acceleration of 0.5 meter per second squared? So there's a pulling force. There's a force of pulling. And now this force is going to have a horizontal and vertical component to it, I believe. And the acceleration in the direction of x is 0.5 meter per second squared. Do we understand the setup? Yeah.
Well, I drew it different, but now I understand how you drew it.
Okay.
That makes more sense.
Did I draw it right?
Well, yeah, no, you just.
Oh, 35 kilogram wagon.
Two triangles. Can you do it with one, or do you have? Does it make more sense to do two triangles?
Oh, it doesn't matter. This is the handle.
Yeah. Okay. Cool.
So I made the pulling force here, but the same thing. But check it out. We have gravity because Earth and stuff.
And that's 3.
And we have normal force because equal opposite force.
And
stuff.
343.35.
Did you multiply this by 9.81?
Yeah.
340.
3.835.
Can we do 344
Okay.
newtons and 344 newtons? Because this thing is not flying off into the air or burrowing into the ground at an accelerated rate. It's just cruising like a regular old wagon. So, what do you think we're going to do?
Well, what do we need to find?
Ella?
Well, we have to find the pulling force, so that's just the hypotenuse of that right triangle right there, right?
Yeah, we want to find that.
So then it's a 20, 90, 70 triangle.
Can you come off?
Yeah.
20,
So then
90,
would,
and 70. And then all we have to do is, oh,
would the thing going directly forward be the mass times the acceleration?
Well, couldn't
Is
you,
that true?
That would be a
wait,
force.
Mr. Murauskas, if you did like the law of cosine, I think, or no, you just did something to find the hypotenuse, would that work? Or and
So
then
we don't know anything about this triangle. We don't know this
No,
or
the
this or
angles.
this. All we know is the angles.
All
We
the
don't. We have no side lengths.
but
We need a side length though, because angle, angle, angle could be.
Yeah. Must have a side length. What do you think,
Well,
Jasper?
the acceleration is 0.5, right? After this. So you know that this one going that way on the bottom is going to be the force of force equals 35 times 0.5.
I said that.
So let's say
The record
Probably
shows.
does.
a sum of x forces is going to be the mass times acceleration.
It's 17.5.
Yeah.
So let's say the
Oh,
motion, we have motion going this way.
That's just, it would be like 12n
Which is
minus
gonna be-
fn, right?
So how about we say
35.
this is fpx and this is fpy.
What is there, P?
The force of pulling it. Do you want to just call it fx and fy?
That's easier for me.
Okay, let's do that. We'll just call this the force.
Yeah.
Okay. Use the force vector. Fx and fy. So if we look at the sum of forces in the x direction, what are those?
That'll be the force going
it would
Well,
be
something minus 12n.
that one, and then
So
yeah.
F sub x minus 12 newtons equals the mass times the acceleration.
Equals 35.
So we can solve for this.
Solve for the f of x. Okay. Plus 12, okay.
So what is that there?
It's like 29.5.
35 times 0.5. Plus 12. Yeah, 29.5.
So the bottom of this thing is, we could do this for funsies. We could say this is 29.5 newtons pulling in the x direction, such that the net force works out and creates an acceleration of 0.5 meter per second squared. We know this is 20. So if I gave you a triangle that was right,
Oh, we could do sine now.
I think it's cosine.
Or cosine, yeah.
Yeah, so 20 cosine.
Cosine 20 equals 29.5 over that.
yup.
And then just
So
divide
for
by
F.
29. So cosine 20 divided by
Point
20.
032.
I don't think you're doing it right, Jeff.
Yeah.
So you want to get f up here, and then divide. So 29.5 divided by cosine.
cosine 20. Oh yeah.
Oh really? Oh.
F needs to be a numerator.
31.39.
Ah, let's try to do
Yeah, I got that too. 31.4.
Okay.
So this force is 31.4 newtons.
So that's the pulling force.
Yeah. Anyone have an answer key?
That's
Oh,
right.
that's right.
Lots of people.
Word. Do y'all have answer keys except me?
I think so.
Everybody said the teacher.
You have one, but then you gave it to me.
Yeah. Okay. Does that make sense?
Yeah, it does. Now that I do it, like,
Yeah.
what happens when you use pen.
Kai, does that make sense?
wait. So we used
This
FMA
is not me.
to find the x force, and then we just once we found that x force, and we didn't really need to do anything with the 344 with the y forces. So we just did, yeah, okay. And we were given the acceleration.
If we wanted to, we could probably find the coefficient of friction.
Why would we want to do force of friction is 12 newtons, right?
Good
Or
question.
Yeah, this is the force of friction.
12 newtons equals mu times natural force, which is 344.
Yeah.
And then, so like mu is like point something.
Yeah. Anyway, cool. We good, Maya? You hate me?
I feel like I'm good now, but
Uh-huh.
once I try and do it on my own, I'll just be like,
Yes.
Why do we have to minus the 12 on the fx?
Because it's the friction.
Because this
Wait, we have
motion is going this way,
Yeah.
so it's positive, and friction is an opposing force, so it's negative because it's going this way. So you have, I'm being pulled this way, and friction is pulling me this way. So we need to combine those to get the net force.
But what if the 12 newtons is a pulling force? Do we do the same thing? If it's
Well,
not
friction doesn't go in the same direction as motion ever. Friction never helps a brother out.
But
unless
if,
you're like,
if
don't want
if
to go
the
somewhere.
if the friction is opposite pulling force, do we do it in the same way?
The friction's always opposite the pulling force.
But if it's on an ideal surface without any friction and we add an opposite pulling force,
You don't add
It
an
would be
opposite
the
force.
same as friction.
that's what I'm asking.
Yeah.
Okay.
Cool.
Wait. But if the friction becomes greater than the pulling force, it doesn't move.
No, it's
It
No,
goes
it-
backwards.
No, it doesn't.
Well, so that's not a
Because
thing.
if there's too much friction, it just won't move. So it's different
Right.
than a pulling force.
If there's too much
Like
friction,
wood.
like
Right. So that's why there's a coefficient of kinetic friction and static friction.
Do we learn that?
In the very beginning, we said
We
that
learned
there's
Why
that
the
was a
flippity
thing, but we
gibbets?
didn't learn anything about
But
it.
like,
It's just like, oh, this is a thing. And then
Yeah.
nothing else about it ever at all.
because it takes a certain amount of force to break to get something moving. Right, so something is stuck, and then as soon as you pull it hard enough, then it breaks loose and starts sliding. And then there's a different coefficient once it's moving.
Oh, that makes sense.
Oh, yeah, and there's
Yeah.
also a different pulling force. and friction.
The force can stay the same, but there's the friction coefficient changes. Okay, let's attack number 4.
oh, this is where it starts to get dicey.
An inclined frictionless plane, yeah. So it's just like it's made out of ice, and it's got Vaseline on it. An angle of 32 degrees with the horizontal. Here we go. 32 degrees with the horizontal. Find the constant force applied parallel to the incline required to cause a 12 kilogram box to slide down the incline with an acceleration of 3 meters per second squared. So 12 kilogram box. We're going to apply a force to it.
A constant
I think this way, but it's going to be sliding down at 3 meters per second squared. Find the constant force applied parallel to the incline. So that means we're going to make a force here. We'll just call it F. And motion is going to be this way. Motion is going to be in this direction. And it's going to be moving at 3 meters per second squared. Accelerating. 3 meters per second squared. Whew. Okay, so what are the other forces I haven't drawn yet?
The
Gravity.
mass.
Gravity. Gravity wants this thing straight down because gravity likes things straight down. And let's break this down into its components perpendicular to the surface and parallel to the surface. And that's, I'll draw that here. So you see this gravity force here. Well, let's, what is the force of gravity? It's going to be mg.
117.72.
117.7, 118 newtons straight down. But let's break this, let's resolve this into its two parts. Right, I mean this helps me visually to see it like this, as a right triangle. Right, and remember we figured out that this is also 32 degrees.
We did?
Remember we proved, it was like several weeks ago. Remember we showed geometrically that this and this angle are similar? Is
Alright.
it similar triangles?
Yeah, we did something like that.
We did. You just have to take my word for it. We have limited time. Oh yeah, we do. Okay. So, can you find
That side.
why am I breaking the force of gravity into two components?
Well, because it's not sitting on a flat slope. It's sitting on an incline. So we need the two.
So this part of gravity is going to tell me what my normal force is. And this part of gravity is going to tell me the motion force.
Don't we only need normal force for friction?
It's a frictionless.
But if it's a frictionless plane, do we not need it?
Okay. Alright, so maybe we don't care about that one. But we do care about that motion force.
Okay.
So how are we going to do that? How do we get this?
Do we trade?
Is that a sine of 32?
Yes. Or yes? Question mark?
Sine of 32 is x over 118.
Sounds good to me. Sine of 32, x over 118. So 118 sine 32?
62.53.
So this force, 62.53, ooh, that's right in the middle. We'll call it 62.5 newtons. Eh?
Oh, because they're parallel, so that means whatever that is 2.
Yeah. So out of the 118 newtons that gravity is tugging on that thing, only 62 and a half of those newtons are in the direction that's going somewhere. Because the other bunch of it is just gonna hit the surface and be neutralized by that equal and opposite normal force.
Yeah.
Okay, so can we
Wait. So we can get f. Oh, f minus 60 or 62.5 minus f, right? Or f minus 62.5.
Well, what is our direction of motion?
We're going down.
It's sliding down here. So we'll call this positive.
Positive 62.5.
So we'll have the sum of forces equals mass times acceleration. And we only care about these forces right now. So this is the motion, 62.5, minus this opposing force that we're going to be pushing on this block is going to give us,
Equals mass 12 times 3. So,
Wait,
36.
but there is no f, because f is 0, so why are we putting that in
no, it says, the question is, what force do we have to push this block with in order to slow down its sliding to 3 meters per second squared? Yeah.
So then you minus.
Wait, where's the 3 come from?
That was given in the problem. It says we want this to have an acceleration of 3 meters per second squared.
So then you just solve for f.
Yep. So,
26.5.
yeah, this minus 36. Yeah. So imagine this is a block sliding down, and it's going to be sliding down super fast, and we're like, slow that beast down. And we're pushing on it, but we're
26.5.
It's like caught
Yeah.
in the...
Oh, the zip line.
Yeah, zip line at Costa Rica. Now slow down.
No, it's like Lily.
And I had to use the emergency.
Lily didn't even slow down.
I was on the freaking platform. My foot almost like clocked me in the face.
Oh man, I didn't think she would go. She weighs like 17 pounds.
No, he didn't.
Just blowing in the wind. God, it's not flying. Okay, we have a couple minutes. Let's try to finish the last one.
Yay. And I put it on Wednesday.
Okay, a 23 kilogram box is released from the top of an incline. Could have just kept the picture. 25 degree from the horizontal. This box is 23 kilos. A 30 Newton friction force impedes the motion of the box.
Does that mean like stops it?
Yeah. So we're going to say motion is this way, but friction is going to be opposing it by 30 newtons. What will be the acceleration of the box as it goes down the hill? What is the coefficient of friction?
That's a good question.
All right, we can do this. So, gravity, how you doing? So gravity is down here,
Oh yeah.
but that's going to be broken down into this part and this part.
So then that angle is 25, right?
Yep. Oh, so what is our force?
Oh, 23 times 9.81.
Yeah.
225.6.
225.6.
225.6.
Alright, so then sine of 25 times 225.6.
Yep. Focus.
95.3.
So we have 95.3 newtons.
Wait, how did
Oh no, I didn't solve for that one.
Oh, well, damn.
I solved the straight down one.
This one?
Yeah,
Okay. 95.3?
yeah. We don't need that one though.
Wait, how do you know?
We
that's
need them
95?
both.
Oh wait,
Because
and
now
then,
this is going to be a normal force. And we need that for friction.
Don't you already have friction?
no, not for this
Sure don't.
We don't?
And then we have the we don't. We have friction, but we don't have the coefficient.
We have the friction force,
Isn't that what you...
but we need the
Oh, wait.
coefficient.
Never mind, they asked for that.
So now we have that. Okay, wait.
Did you do a cosine or a sine?
I did sine.
Well, then that's this one.
No, because I did 25. Oh.
You are snapping. You are making me look like a fool right on camera.
Sorry.
In front of God and everybody.
Wait, so cosine 25.
Cosine 25 degrees, close your
Times.
dang parentheses.
225.6.
How's that?
204.5.
204.5 newtons. That's going to be your normal force, 204.5 newtons. And then was it 95.3?
Yeah. Wait, you wouldn't use 25 for that.
Yeah, you would. Because this angle, we're finding this side of that.
90.
We have different answers.
Oh. Okay.
9.81.
Oh, go ahead.
Are other people doing this besides Ella?
Yeah.
Yeah?
So then that's
So did you guys
force.
break
Where'd you
these?
get the 225? Is that the 23 times 9.81?
Yeah.
Yeah. And then we broke this weight down into perpendicular and parallel
Perpendicular.
forces to the incline. And
now we have the forces. We just need to do the acceleration. So now we do some of the forces, which is 95.3 minus 30. And that's 65.3 equals mass, so 23a, and then that divided by 23k. And then you get 2.8 is meters per second squared.
You guys with it? Now, someone besides Ella, how do we find that coefficient of kinetic friction?
All of the forces. No.
You do the
Maybe.
force of friction.
Oh, and then you do
That's I didn't know.
you do
Or-
30. I'm sorry.
Wait.
Wait,
You
it's
do the
times
force of friction divided by the normal force.
There you go.
Yeah.
Yeah. Which gets you that number.
0.13.
No units.
Why would I not do that before?